Hello and welcome everyone. This is Mohammed Zaman from SAIMEDHA Coaching Center, Koti, Hyderabad. SAIMEDHA Koti, Hyderabad is providing every single day free educational content in our YouTube channel. So my dear students, those who have not watched this video lecture entire series, guys, please go through all the previous video lectures and watch. This is the video lecture number 6. In this very video lecture, we are providing the free educational content for AE-AEE-CIVIL aspirants. Subject is fluid mechanics, topic is fluid properties. This is video lecture 5. In this video lecture, we are going to be discussing about the concept regarding the fluid property viscosity. Upon which parameters the viscosity is going to be dependent, what is Newton's law of viscosity, what is the Newton's law of viscosity, what are the list of properties, some units of the properties also we are going to see and watch in this very video lecture. My dear students, free educational content itla provide chestunnam, meer kuda encourage cheyali ana udeshamto please press that bell icon and subscribe our channel. Like cheyandi, share cheyandi, mee friends to information ni pass cheyandi. So let's get started this video. At the end of this video, I am having a golden opportunity for all the AE-AEE aspirants. Let's start the video now. So let's continue with the next property that we have now after the completion of specific weight is specific gravity. Specific gravity is also called as relative density. The word itself indicates relative density, that is ratio of densities. Ratio of densities here we have. So specific gravity is denoted by letter S. It is going to be comparing the density of any solid liquid vapor with density of standard. That standard fluid is water. Standard fluid is water. So we can write the formula as density divided by density of water is 1000. So specific gravity is density by 1000. So density can be written as specific gravity of a material times of 1000. If I multiply the same formula here, density divided by density standard with acceleration due to gravity, rho g formula is specific weight. So specific weight divided by specific weight of standard. Specific weight divided by standard specific weight is specific weight of water. So the formula for S is going to become S divided by what is the standard specific weight? Water, 9810. With which gamma we can write as specific gravity into 9810. So what is the formula? What is the ratio? Relative density formula can be written as ratio of density of solid liquid vapor of any material to density of standard fluid. What is the standard fluid here? Water. So what are the two formulas for the specific weight we can write? Specific gravity is equals to density divided by 1000 or specific gravity is equals to specific weight divided by 9810. With which the formula for density we can write as specific gravity into 1000, specific gravity into 1000, or specific weight formula we can write as specific gravity into 9810. Okay. Now, what are the units of specific weight, specific gravity? Here we have density divided by density. So units will be density divided by density. It is kg per meter cube divided by kg per meter cube. Let's cancel. What is the answer? No units. Okay. Let's write all the units and dimensional formula at one place. First of all, pause the video and note it down so that we can go for the next slide. Okay. Go through it. Let me go for the previous slide also if you haven't noted down it. Specific weight. In the previous slide we discussed about weight. Then we discussed about specific volume. Specific volume density are reciprocals to each other. And then we discussed about density concept also. Okay. Wherever you have not copied, guys, pause the video and note it down. There are standard density values, temperature relation with densities, specific mass density. Okay. So let's go to the last slide and continue. So here we have specific weight. So the next one is, let's see the dimensional formulas now. because if any dimensional formula is asked, you should be able to write that also. First one is area. Area is what? Meter square. So we can write L square. Second one is volume. Volume is meter cube. So we can write L cube. Length cube. Third one. Third one is specific mass. Specific mass is kg per meter cube. It is m by L cube. It is ml to the power of minus 3. Mass length per minus 3. Then we have specific weight. Specific weight. Specific weight is Newton per meter cube, where Newton is kg meter per second square per meter cube. Meter square. So this is going to become kg per meter square second square. M by L square T square. It is ml power minus 2 T power minus 2. Specific weight. Okay. Similarly, fifth one. Specific volume. Specific volume is reciprocal of specific mass, meter cube per kg. That is L cube by m. That is m power minus 1 L cube. M power minus 1 L cube. Then we have specific gravity. Specific gravity, no units. No units, no dimensional formula. Okay, go through it. So now we know so far what properties we have discussed, their dimensional formulas. So pause the video and note it down so that we can go for the next property. Pause the video and note it down. Let's go for the next one. So the next property, let's continue the topic. In this topic we are going to discuss about the next property, that is viscosity. The term viscosity represents to dynamic viscosity. Okay, another name for dynamic viscosity is coefficient of viscosity, which is also called as absolute viscosity. In some textbook, for question to twist, he is going to use the word kinetic viscosity. Kinetic, dynamic, coefficient, absolute, or simply viscosity, which is denoted by symbol mu. Okay, which is denoted by symbol mu. Actually, what is the definition for viscosity? Property offers resistance to flow when fluid is under layer by layer transitions or layer transitions. This layer indicate lamina or laminae. Flow is called as laminar flow. Laminar flow, another name is oil flow, retarding flow, viscous flow, military flow, one dimensional flow, viscous flow. Okay, that is military flow, one dimensional flow, retarding flow, decelerating flow, retardation, deceleration, same. So here we need to focus upon this one word, viscous, laminar, laminae, layer by layer transition. Okay, resistance it is. So when the fluid is under flowing, observe, this is liquid under layer by layer transitions, one layer over the other. And when the first layer is under motion, second layer is going to be creating some resistance over it. Okay, some shear resistance. when molecule of same substances are attracting each other, okay, that is called as cohesion. Cohesion, phenomena with which molecules of same substance attract each other. Molecules of same substance, molecules of same substance attract each other. Attract each other. So now we know that when first layer is moving, second layer is creating the resistance. Let's say that is a shear force or viscous force is a resistance. It is due to the molecules of same substance, that means same molecular attraction. That means viscosity depends on this property, that this point we need to memorize now. Viscosity in liquids, viscosity in liquids depends on dash. Your answer should be intermolecular cohesion. Intermolecular cohesion. Go through it. What is actually viscosity name? Viscosity, dynamic viscosity, coefficient of viscosity, absolute viscosity, kinetic viscosity, denoted with symbol mu. What is the definition? Property offers resistance to flow when fluid is under the layers, transitions, laminar flow, retarding flow, viscous flow, one dimensional flow. When layers we have drawn in the liquids, when first layer is in motion, second layer is giving some resistance. Okay, then first layer is under motion, second layer is giving some resistance, offering some viscous forces. Sir, why these viscous forces are coming into existence? Because molecule to molecule attraction is there. That means viscosity in liquid is depending upon what? Intermolecular cohesion. Cohesion means what now? Cohesion is a phenomena with which molecules of same substance attract each other. Okay, if you see in vertical direction, you are going to be having some gradient in the velocity. Velocity is going to be changing with respect to the direction perpendicular to the flow. Velocity is changing. Okay, velocity changes. Velocity changes with respect to the axis perpendicular. This we discussed in the no slip condition also. Perpendicular to it. This produces the rate. This produces the rate at which with respect to the which velocity varies, to which velocity varies and is known as velocity gradient. What is it known as? Velocity gradient, change in the velocity in y direction. When velocity gradient is produces a field of shear force and a field of shear force which is given by Newton's law of viscosity, which is given by Newton's law of viscosity. So what is this Newton's law of viscosity? We will see, but for now let us see the all important points regarding the viscosity that we have discussed so far. Names of the viscosity, denotation of viscosity, definition of viscosity. Viscous flow is called as laminar flow. In case of liquid, when molecules are moving on the first layer, second layer is going to be attracting the first layer, causing some resistance. That is due to intermolecular cohesion. So viscosity in the liquid depends upon intermolecular cohesion. We are having momentum transfer also, but who is predominating? Intermolecular cohesion. So we can write this point as viscosity in liquid. Viscosity in liquid intermolecular cohesion predominates intermolecular momentum transfer. Intermolecular momentum exchange or intermolecular momentum exchange, let's write intermolecular momentum exchange. In case of gases, intermolecular momentum exchange will be more. Okay, this point is also important. Intermolecular cohesion predominating the intermolecular momentum exchange in case of liquid. In case of gases, intermolecular cohesion is not going to be having that effect in comparison with the intermolecular momentum exchange. Okay, go through it. So now the velocity is changing with respect to y direction. In the no slip condition also I have given this diagram, that velocity at the boundary level, at the outermost surface boundary, at the stagnated rest condition, velocity is going to become 0. Then we discussed about laminar flow and Coulter flow also. Okay, Coulter flow. Let's move on to the next point where we in detail let's discuss about the next one, that is Newton's law of viscosity. Engineering services question, how he is asking about Newton's law of viscosity? Let's see. Newton's law of viscosity. He framed the question options as shear stress directly proportional to shear strain, shear stress directly proportional to rate of shear strain, rate of shear stress is directly proportional to shear strain, or rate of shear stress is directly proportional to rate of shear strain, angular deformation. Okay, based on which we are going to memorize the correct answer, and we can see how easily he is framing the question, twisting the options. Okay, so the correct answer is what? Option number B, it is shear stress is directly proportional to rate of angular deformation. So what is the definition going to become? Newton's law of viscosity, it states that for fluid in motion, shear stress or tangential force applied is directly proportional to rate of 5 is angular deformation, rate of angular deformation, rate of angular deformation. Rate of angular deformation can be treated as shear strain rate. Okay, in the previous slide itself I told you that rate of shear strain is velocity gradient dV by dy. We discussed about this when we were discussing about the no slip condition. d phi by dt, dV by dy, both are going to become equal to each other. So what is it called as? Shear strain rate or rate of angular deformation. Rate of angular deformation. dV by dy, what is it called as? Velocity gradient. So when both are equal, we can write two formulas. Formula number 1, shear stress is directly proportional to rate of angular deformation. Now formula number 2, what we can write here? Replacing the rate of angular deformation with velocity gradient, dV by dy. Go through it. Tau is directly proportional to what is second formula now? dV by dy. Okay. Rate of angular deformation. So now tau is directly proportional to dV divided by dy. Then proportionality sign gone, you need to put a constant. So what is a constant now?
tau is equals to, this is dynamic viscosity, tau is equals to mu dV by dy. That I told you in the previous slide, tau is equals to mu dV by dy. What is this mu? Mu is viscosity, dynamic viscosity, coefficient of viscosity, absolute viscosity or kinetic. Kinetic viscosity is different from kinematic viscosity. Okay, go through it. So now this mu is absolute viscosity, dynamic viscosity, coefficient of viscosity. For now I need to write any one name, so I am selecting dynamic viscosity. Mu is dynamic viscosity. Okay, when the velocity profile is parabolic, this holds good, this formula. Okay, suppose this is a rest, plate in the rest, and here we are having velocity gradient. So velocity is changing with respect to y direction, where here velocity is 0 and here velocity is maximum. Velocity is maximum. Under linear velocity profile, okay, let me go for the next slide so that you can understand it much better. For that, first of all, pause the video and note it down. Statement is important, formula important, this formula important, tau equal to mu dV by dy. Okay, how is asking the question? Newton's law of viscosity. See, one of the very most important specific topics in all the properties where we need to put our entire focus, okay, is first one, viscosity only. Okay, where from where you can see maximum number of questions in the previous GATE examination, ESE examination and PSU's examination. Okay, go through it.
Congratulations guys on making it so far. You have watched the entire video. I hope this video you might have little bit definitely your information, your knowledge regarding the subject viscosity definitely have been improved. So my dear students, SAIMEDHA Hyderabad is providing free of cost coaching for AEE and AE. Yes, you heard it right, up to 100% we are providing the concessions based on a talent test examination that is going to be conducted in SAIMEDHA Hyderabad tomorrow, 11th of February morning 10 o'clock sharp. SAIMEDHA premises lo ide chapter fluid mechanics sambandhinchina fluid properties lo మీరు talent test examination రాయబోతున్నారు. That is SST, Space Scholarship Test for AE coaching for civil students. My dear students, మీకు ఏదైనా డౌట్ ఉన్నా ఖచ్చితంగా మన స్క్రీన్లో ఉన్న మొబైల్ నెంబర్కి కాంటాక్ట్ చేయండి. డౌన్లోడ్ ది యాప్ స్పేస్ గేట్ యాప్ అనేది మీరు డౌన్లోడ్ చేసుకోవాలి. దాంతోపాటుగా డిస్క్రిప్షన్ లో ఉన్న టెలిగ్రామ్ ఛానల్ ని కూడా జాయిన్ అవ్వండి. మై డియర్ స్టూడెంట్, దోస్ హు ఆర్ గోయింగ్ టు బి రైటింగ్ దిస్ ఎగ్జామినేషన్ మినిమం 85%, 87, 89, 90, 91, 100% వరకు ఫుల్ ఫ్రీ స్కాలర్షిప్స్ are going to be provided for all the students, those who are going to be appearing, attempting and getting so and so marks. So my dear students, what are you waiting for? Start preparing for your space scholarship test and don't forget tomorrow's date, 11th of February, SAIMEDHA Hyderabad lo. Yes, we are conducting this test. Ee information ni maximum me friends, me circle, me students, me faculties, entire civil students ki diploma complete aina prati okkariki ee video ni share cheyandi and ashistu. This is Mohammed Inzamam signing off with one more video. I'll come back tomorrow. Thank you very much guys. Take care.